Hi everyone, I am Dr. V.H. Nishok from AC Department, SNS College of Technology. Here we are gathered to discuss the topic analog to digital conversion in microcontrollers. So this is the outline of our video, which starts with real world analog signals and the problem of microcontroller and what is the solution and the types of A to D converters and key A to D converter specification and its applications. So coming to the real world analog signals. So by using the sensors while measuring any physical quantities like temperature, sound, humidity, pressure, light, etc. So the sensors produce the analog signals. Here the signals are continuous in range. So because the signals are continuous in range and it is analog signal, the microcontrollers works only with the binary, that is zeros and 1. So here the issue is we cannot directly give the analog signal to the microcontroller, so we need to convert first the analog signal to digital signal. So that is the problem statement we have identified. So and the best solution for it is A to D converter. So we are converting the analog signal into digital binary output, equivalent digital binary output with the help of the A to D converter. So which provides the binary output, which output, this output of ADC is further given to the microcontroller unit. So the A to D analog converter consists of the three main steps, that is sampling, quantization and encoding. The sampling is nothing but taking the signal, the analog continuous input signal at a regular time period, taking the analog continuous signal at the regular time period, and it is given for quantization. So the quantization is nothing but rounding of the analog values to the nearby discrete values. So that is nothing but the quantization. And then encoding. So here with the help of the sampling and quantization, the analog signal is converted into the digital in the form of amplitude and time period. So the digital output should be given as the equivalent binary value. So that is done with the help of the encoder circuit. So with the help of the sampling, quantization and encoding circuit, the analog signal is completely converted into the equivalent digital signal in the binary form. So here are the main types of ADC. So we are seeing here flash type ADC, successive approximation type ADC and dual slope type ADC. So both everything is based on its features. So coming to the key A to D converter specifications. So specification which determine the performance are resolution, accuracy, sampling rate and conversion time. So resolution is represented in number of bits. As like camera quality, low resolution mentions the blur output and high resolution represents the clear output. And accuracy, how the output of the A to D converter is equivalent to the real signal. And the sampling rate, how many number of samples taken per second. So that is nothing but represented as a sampling rate. And conversion time, so how quick the signal is converted from analog to digital. So these are the performance measured features of the A to D. So coming to the applications of A to D converters. So it is widely used in sensor data acquisition, digital thermometers, audio recording and embedded systems. So here is the summarization part of the A to D converter. So in this video we have seen the need for A to D converter and A to D conversion process and types of A to D converters and its key specification along with its applications. So here the time for assessment. So what is the sampling done? So sampling converts the signal with respect to the regular time intervals. So answer is B. So the next question is resolution depends on bits. Resolution depends on the number of bits. So these are the reference books and reference URLs, websites that we have used for this video. Thank you all for joining this video.